Hi, I'm David, and I'm going to show you some of the integrations we've been working on between Geogebra and our tool, Graspable Math. So Graspable Math is an interactive and dynamic algebra system. What it lets you do is take terms, move them around, rearrange them according to mathematical rules, so that you can get fast, dynamic, shareable online math expressions that you can have some guarantee have been operated on in ways that are legitimate. So it builds a safe space to play around with graphical and dynamic mathematical notations. What I really want to show you today, though, is that integration with GeoGebra. So here I've started to set up a situation that one might face pretty often in an early middle school or early high school math curriculum. So here, I'll just flesh out a little bit. Let's assume we've got two equations and two unknowns. And again, we might pick these up, move them around, rearrange them. You can do things like solve for y. You can do a variety of basic operations inside Graspable. You can also interact with the GeoGebra system. So what you might want to do, of course, is not just look at these lines and manipulate them algebraically, but look at them. And there you can see by dragging the circle attached to the line into the space in between GeoGebra and Graspable, we can produce graphs of these lines. We can also see which line goes with which equation by highlighting over them inside that interactive space. So in a fairly typical situation here, one might look for the point of intersection between these two lines, right? The point that satisfies both of them. So we know that's going to be a point xy, and it's going to satisfy each of these equations. There's a couple of standard ways to do this. You can do them inside Graspable Math. I'm going to show you the substitution method, and I'm just going to basically run through it really quickly to show you how things work. Of course, in a real math class, you might spend quite a while understanding the individual steps that I'm going to move through quite quickly here. There we go. And notice that here what we've got is not just an answer, but also an unfolded proof that shows, or an unfoldable proof, which can be emailed, which can be shared, which can be manipulated in a live way, and which sort of shows you the steps that you would go through and that we're going through to get to these answers. So now what I'm going to do is substitute in my solved x value for y. And again, if I were teaching you the content, I might spend a while thinking over these steps, but as it is, I'm just going to drag them in and solve it, and then back substitute to get my value for x. And now we substitute in here, and now we've got x and y values that show us the answer to these two equations. And if we wanted to, we could go ahead and solve that and show it, but instead what I'm going to do is just drag this point into the space between and show you that sure enough, we got the point. And this point, I think very nicely, is dynamic in two important ways. So one way that it's dynamic is that it's a full-fledged GeoGebra object, so not only can we work with it, we can now, say, build new lines off of it. Right? We can think about its interactions with other GeoGebra elements if we want to. We can even, build a triangle off of these things and build a polygon that now will interact with that A term. And then, because we kept these proofs as objects, right, because these histories are unfoldable, we also can update that proof in response to counterfactual scenarios. So we can say, well, what if that line had been a little bit different? What would that point of intersection have then been? Right? And by scrubbing these values around, oops, unless it comes out of sync, by scrubbing these values around, we can keep track of what that proof would be under various counterfactual scenarios, and you'll see the triangles, the lines, everything else updates appropriately inside GeoGebra. So what we hope to be able to do is set up these environments in which we create safe explorable spaces that combine geometric perspectives on numbers and algebraic and proof perspectives on numbers. And that is what I wanted to show you.